In this video, we're going to be working through the conservation of momentum questions covered in the collisions lesson. So the first line, remember, the law of conservation of momentum says that the total momentum before an event is equal to total momentum after an event. This statement can be written in the following equation. Total initial momentum is equal to total final momentum. Super important equation, and we're going to be using it throughout this exercise, so I'm going to highlight it. So let's move on to question 1. So a car of mass 1,000 kilograms is traveling at a velocity of 20 meters per second. Let's call that car object A and highlight its information in blue. So that's its mass and velocity of car A, of object A. Collides with a stationary car of mass 1,000 kilograms. It's stationary, that means it has a velocity of 0. So just to make that clear, it has a velocity v equals 0 meters per second. Afterwards, the vehicles move together after the impact. We have to calculate their velocity. So the first step would be to draw a table so we can consider what's happening in our system before and after the collision, like such. Before collision, we have one car traveling at 20 meters per second colliding into a stationary car. Let's label those A and B. A and B. Now, what do we know about A? A has a mass of 1,000 kilograms and has a velocity of 20 meters per second. Has a momentum equals mass times velocity. The momentum of A, let's say momentum A, of A is equal to 1,000 kilograms times 20 meters per second. And this is equal to 20,000 meters per second. Now let's look at B. B, on the other hand, has a mass of 1,000 kilograms. However, it has a velocity of 0 meters per second as it's stationary. So its momentum, as we saw before, momentum is equal to mass times velocity is equal to 1,000 kilograms times 0 meters per second. This is equal to 0 kilogram meters per second. So now the overall momentum, or a better way of saying it, total initial momentum is equal to 20,000 kilogram meters per second. Now let's look at what happens after collision. So we have object A and object B. And in this case, they move together after collision. So, as we revert back to our initial equation of total initial momentum equals total final momentum, we know that the total final momentum is equal to 20,000 kilogram meters per second, as is equal to the momentum before the collision. We also know that as the bodies move together, their mass is combined, and the total mass is therefore 2,000 kilograms. Velocity, however, is unknown, so let's just call that v. According to our equation, momentum equals mass times velocity. Velocity can be found by rearranging this equation. Equals momentum divided by mass. If we substitute in our values, let's move this up a bit. Velocity equals 20,000 kilogram meters per second divided by our mass of 2,000 kilogram. 20,000 divided by 2,000 is 10 meters per second. So our final answer is velocity equals 10 meters per second in this direction. And that's our final answer. Let's jump to part 5. So again, let's read the question and highlight the relevant information. A van of mass 5,000 kilograms is traveling at a velocity of 10 meters per second. Let's call this van object A and highlight its information in blue. The van collides with a stationary car. Let's call that object B. Stationary means it has no velocity. And the vehicles move together after impact. They move together, very important, at a velocity of 6 meters per second. Again, very important. Calculate the mass of the car. That's the mass of object B, so we'll highlight it in blue, in red rather. Once again, let's bring up our table to analyze our bodies, body A and body B, before and after the collision. So before collision, we have body A moving towards body B. Body A is in blue, and body B again is in red. So what do we know about body B? Body A, the van. The van has a mass of 5,000 kilograms and a velocity of 10 meters per second. As momentum equals mass times velocity, the momentum of the van, what we'll call body A, is equal to 5,000 kilograms times 10 meters per second, which is 50,000 kilogram meters per second. Now let's look at body B. The mass of body B is unknown. Let's call that mb. But the velocity of body B is equal to 0 meters per second. As momentum is equal to mass times velocity, the momentum of B is equal to mb, the mass of B, times 0 meters per second. And anything times 0 is 0. So the momentum of B is 0 kilogram meters per second. As a result, the total initial momentum of A and B is equal to the momentum of A plus the momentum of B, which is 50,000 kilogram meters per second. Now let's look at what happens after the collision. We have body A and body B moving together this time after they collide. That's body A and body B moving together in the same direction. So, according to the law of conservation of momentum, total final momentum is also equal to 50,000. Don't forget the units. The velocity of body A and B is 6 meters per second, as given in the question. And the mass of both A and B, let's say MB, rather MA plus MB, this is equal to 5,000, which is the mass of A, 5,000 kilograms, the mass of A, plus the mass of B, which we don't know. Let's call that MB. Now let's write our momentum equation. So we know momentum and we know velocity. We're trying to find a component on mass. So if we rearrange this equation, we can find that mass is equal to momentum divided by velocity. And if we substitute our values into this equation, we can find that mass, which is from here, 5,000 kilograms plus MB, is equal to 50,000 kilogram meters per second divided by 6 meters per second. 50,000 divided by 6 is rounded up 8,333 kilograms. Now let's rewrite this equation to make everything a bit more clear. kilograms plus MB equals 8,333 kilograms. Therefore, MB is equal to 8,333 kilograms minus 5,000 kilograms. And MB equals 3,333 kilograms. I'm going to highlight it just to make it a bit more clear. We highlight it in red. That's the final answer. So let's take a look at part C, our challenge question. As with any question, firstly, let's read the question and highlight the relevant information. So, a shotgun of mass 3 kilograms fires a bullet of 0.1 kilograms at a velocity of 250 meters per second. What is the recoil velocity of the gun? So the shotgun, let's call that body A, has a mass of 3 kilograms. And it fires a bullet, let's call the bullet body B, which has a mass of 0.1 kilograms. So that's our initial information. Let's imagine a shotgun being fired. Initially, neither the shotgun nor the bullet has any speed, especially in this question. However, after it's been fired, the bullet begins to move at 250 meters per second. And as it's fired, the shotgun recoils. So that's its velocity after the collision. If we go back to our 3 types of collisions, recoil was the 3rd type. It might be worth revisiting that. So our final velocity of our shotgun, let's highlight that in light blue. That's our recoil velocity. Now final velocity of our bullet, let's call that Let's label that purple. So, as with all questions, let's pull up our table. So our initial before collision, we can have body A and body B together. Let's label that body A and body B together. So we know the mass of body A is 3 kilograms and the velocity of A is 0 meters per second. What about B? B has a mass of 0.1 kilograms and a velocity of 0 meters per second again. So momentum in both cases is equal to 0. So as total initial momentum is equal to the total initial momentum of A and the total initial momentum of B, the total initial momentum is equal to 0 kilogram meters per second. So according to the law of conservation of momentum, we know that the total final momentum is also equal to 0. Let's write that here. Now, let's go back to our two bodies. Now remember, after the collision, we have different colors for them. So we've got B and A, just to make things clear. Let's label B and A. A is here, moving in this direction. Remember, it's recoiling from body B, bullet, which is moving in this direction. So what do we know about this body? So let's do A on this side. The mass of A is 3 kilograms, and the velocity of A is unknown. Let's call that VA. Now the mass of B, on the other hand, is equal to 0.1 kilograms, as we saw before. The velocity of B is equal to 250 meters per second. Let's look at the momentum of each now. The momentum of A is equal to 3 kilograms times VA. And the momentum of B is equal to 0.1 times 250, which is equal to 25 kilogram meters per second. Now the equation for total final momentum is as follows. Let's write that a bit higher. Equals the momentum of A plus the momentum of B. Yeah. So we know that total final momentum from above is equal to 0. So 0 kilogram meters per second is equal to momentum of A, which is from above 3 kilogram times VA. And the momentum of B is equal to 25 kilogram meters per second. So by rearranging this equation, we can find that 3 kilogram times VA is equal to minus 25 meters per second. And our final answer of velocity of A is equal to minus 25 kilogram meters per second divided by 3. So let's draw a little box here to make it clear. The velocity A is equal to minus 25 divided by 3, which is equal to minus 8.33 meters per second. And that's our final answer.